In this video lecture, we are going to talk about the flow and also production of CSF. All right, the production and flow of CSF. So CSF is actually standing for cerebrospinal fluid. Cerebrospinal fluid. Okay. Now, we have the brain ventricles. Okay, we have the lateral ventricle, we have the third ventricle, we have the fourth ventricle. Okay, now in this case, this CSF, cerebrospinal fluid, is actually produced in these ventricles. Now, most of it is actually produced in the lateral ventricle. So let's actually talk about how this fluid is going to move from the lateral ventricle, third ventricle, and fourth ventricle. But before we come to that, I need to explain to you that in these ventricles, we have what we call the choroid plexuses. Okay, so in the lateral ventricle, the choroid plexuses actually is found in the walls of the ventricle. That's where you are going to find the leaf-like structures that will actually produce, the CSF, which is the cerebrospinal fluid. Then, the choroid plexuses actually is also found in the roots of fourth and third ventricle. In the roots of third ventricle and fourth ventricle. In this case, so the cerebrospinal fluid actually is constantly produced at a secretion rate of 0.2 to 0.7 mils or rather milliliters per minute, meaning that there is about 600 to 700 mils of newly produced CSF per day. Now, since the total volume of CSF averages around somewhere 150 to 270 mils, this means that the entire volume of CSF is replaced every 4 times per day. Okay, replaced around 4 times per day. Now, in this case, the pathway of cerebrospinal fluid is as follows. I'm going to explain in a little bit details, but on the surface so that you understand it better. Okay, let's now enter into the nitty-gritties of how it flows. Now, the CSF passes through the lateral ventricles, okay? Or rather, it is produced in the lateral ventricles. Then it will actually enter, okay? It will enter, or rather go to the third ventricle through what we call interventricular foramina, okay? Interventricular foramina, or in other words, it's called foramina of Monro, okay? Foramina of Monro. Now, from the third ventricle, the CSF flows through the cerebral aqueduct, which is also known as aqueduct of Sylvius, to the fourth ventricle. In this case, now, from the fourth ventricle, here is where you need to now understand clearly. I want everybody in this case to understand clearly here, because a lot of people find it difficult to understand how the fluid will escape the fourth ventricle to the spinal fluid, to the spinal cord, and also to the bloodstream. Now, here is what happens. So from fourth ventricle, some cerebrospinal fluid will actually flow through a narrow passage which is called the orbex. Okay, orbex, and enters the cerebral canal of the spinal cord. However, the majority of CSF passes through the apertures. Okay, they passes through the apertures of the fourth ventricle. Now, we have what we call the median aperture, which is also called aperture of, Magendie. Okay, aperture of Magendie. Then we have another two. Okay, the lateral apertures. Okay, the lateral apertures, or they are also called, apertures of Luska. Okay, so via these openings, the cerebrospinal fluid will actually enter the cisterna of Magna. Okay, and then also, the cerebellopontine. Okay, cerebellopontine cisterns. Now, from there, the cerebrospinal fluid actually flows through the subarachnoid space of the brain and also the spinal cord. Okay? Therefore, it will finally be reabsorbed into the dura venous sinuses through the arachnoid granulations. Okay. Now, this is how the cerebrospinal fluid is produced and then flows. Now, in addition, actually, or rather in conclusion, there are three recognized routes through which cerebrospinal fluid exits the subarachnoid space. Okay? Now, the subarachnoid space, or rather let me say there are three recognized routes, okay, through which the CSF exits the subarachnoid space to enter the cerebrovenous system, the one that I just mentioned. Okay, therefore we have arachnoid granulations, minute channels that pass through the cribriform plate of ethmoid bone. Okay, yeah, now I remember very well. Now I remember ethmoid bone. I repeat, through these three recognized routes, I said we have what we call arachnoid granulations, minute channels that pass through the cribriform plate of ethmoid bone, and also the glymphatic system, not the lymphatic, but the glymphatic system. Okay, of which we are going to talk about these in details. Okay, we are going to talk about these in details. So as for today, we can actually end here. So I have added some few information that I'm going to explain in the next video. Stay tuned and make sure that you stick around to this page, and make sure that you invite and share with friends. Thank you so much for watching.